Alright guys, in this video we're going to talk about some numerical summaries, and the very first definition I would like to introduce is called arithmetic mean. Let me pull out the marker. Arithmetic mean. So I guess some of you may have heard this definition, whatever, in the daily life or in other classes. This is pretty straightforward. But let's take a look at the exact definition of the arithmetic mean. The arithmetic mean of a variable is computed by adding all the values of the variable in the data set and dividing by the number of observations. So basically, if you want to find out the arithmetic mean of a data set, first of all, you want to add all of the values together and divide by the number of observations. For example, if I gave you a data set, let's say 3, 2, 7, 8, and 9. So if you want to find the arithmetic mean of this data set based on the definition, we want to add all the values together, 3 plus 2 plus 7 plus 8 plus 9. And then divided by the number of observations, which is 5 here. And then, so 3 plus 2 is 5, 5 plus 7 is 12, plus 8 is 20, 29 over 5. Of course, you can convert it to decimal places, but I don't want to do it over here. So that's pretty much the basic idea of how to calculate the arithmetic mean. And based on what we learned in the section 1.1, we know that we're gonna learn two kinds of numerical summaries. One is called a parameter, and one is called the statistic. Parameter goes with the population, statistic goes with the sample. So of course, since the mean is the numerical summary or numerical measure, we're going to have the population mean and sample mean. First of all, let's take a look at the population mean here. The population arithmetic mean, actually we just call it a population mean, pronounced by mu. So this is called mu. It is computed using all the individuals in the population. So basically, if you have a population data set, the mean you get would be called the population mean. And of course, the population mean is a parameter. Now let's take a look at the sample mean. The sample arithmetic mean, x bar, that's pronounced as x bar, is computed using data set. And the sample mean is a statistic. So basically, if the given data set is sample, then you will have a sample mean. Now, let's take a look at the formula. Pretty straightforward. So if x1, x2 through xn are the capital N observations of a variable from a population, of course, we're gonna calculate the population mean mu, so which is equal to, we add all of the x values together on the top and then divide by the n here. So if we want to make it look more clear, we can put at the top in a summation form. So this symbol over here is called a summation. This means the sum of all x values divided by the number of observations, capital N. That's the formula for the population mean. Now let's take a look at the formula of the sample mean, which is very similar. So if we have x1, x2 through x little n are the little n observations of a variable from a sample, then the sample mean x bar is equal to, once again, we add all the x values together on the top and divide by the little n. And if you want to put it in a summation form, so this represents the sum of all x values in the data set divided by n. That's the formula of sample mean. Now, once we know the formula, let's take a look at example here. Computing the population mean and sample mean. The following data represent the travel times in minutes to work for all 7 employees of a startup web development company. So we get 7 numbers over here. Of course, in this case, this data set is considered as a population data set. Part A, compute the population mean of the data. So based on the formula we just went over, the population denoted by mu, that would be equal to, we add them all up, 23 plus 36 plus 23 plus 18 plus 5 plus 26 plus 43 divided by the number of observations, which is 7. So that's pretty much how we calculate it. I wouldn't simplify over here because I'm gonna give you the answer on the next slide. So that's about part A. Now about part B. So then take a simple random sample of n is equal to 3 employees, compute the simple mean. So basically we can randomly pick up 3 numbers from the 7 numbers as the a sample data. So we can just randomly pick up any 3 numbers. Let's say 18, 5, or 26. So if this is our sample, the simple mean x bar would be equal to, we add them all up, 18 plus 5 plus 26, and then divided by 3. That's pretty much how we calculate the sample mean. Of course, on the test or on the homework problems, you get a calculated and got the simplified answer at the end. Now let's take a look at the answer. So for the part A, the population mean is equal to the sum of all x values divided by the capital N. So we get all the 7 numbers on the top here and then divided by 7. And then it's 174 divided by 7. That's 24.9. I think it's approximately, excuse me, minutes. That's pretty much how we calculate the population mean here. And then let's take a look at part B. Actually, in this case, they select these 3 numbers, 5, 36, and 26, plus, divided by 3, and got the simple mean 22.3. But anyway, we picked another 3 numbers and got another simple mean, but the philosophy is the same. And this instruction here is, I think that's from the calculator, about how to randomly pick up 3 numbers from the data set. So we don't have to worry about this part over here. Okay, we just need to know how to find the simple mean and population mean. And that's it. I think it's pretty straightforward. Now, once we know how to find the population mean and simple mean, and the next definition is called the median. The median of a variable is a value that lies in the middle. The median lies in the middle of the data when arranged in ascending order. So basically, based on the definition here, if we want to find a median, first of all, we want to rearrange the data set in ascending order and find the number in the middle position, and that's it. So let's take a look at an example here. I will come up with an example and show you how to figure it out, and then we're gonna see the exact examples in the slide. So let's say the data set, let's say 2, 5, 7, and then 3, and then 8. Okay. So I gave you the data set with these 5 numbers, and if we want to find out the median of the data set based on the definition here, we want to rearrange this data set in ascending order first. Let's put them in ascending order. That will be 2, 3, 5, 7, and 8. And then find the number in the middle position. So obviously in this case, the middle position is the 3rd one, and the value is 5. So the median in this case is equal to 5. That's pretty much how to find out the median in this case. But the problem is, we only have 5 numbers over here, and it is very easy to pick up the number in the middle position. But what if we have a large number of values? What if that it's not that easy to find out a number in the middle position? Then we need to find the middle position first. Now let's take a look at the position of this number here. This is the 3rd number, right? And we have 5 numbers in total. So the position of the middle number, or the middle position, is the middle position would be 5 plus 1 is divided by 2. This is the 3. That's the 3rd, actually. So once again, this 3 is not the value of the median. This 3 is the position of the median. Now, what if, okay, we have let's say 199 numbers. So what's the middle position? So if we want to find the middle position, that would be 199 plus 1 divided by 2. That is 200 divided by 2, which is 100. This is 100th. This is, once again, this is the position of the middle number. It's not the value of the middle number. Okay, that's how we find out the position. That's pretty much the first case. Now the second case is now what if I just add another number to the original data set. Let's see, 25738, and then I'm going to add a 9 here. Now we got a new data set, and I want to find out the meaning of this data set. What we're gonna do is same thing. We put the data set in ascending order. Rearrange it 2, 3, 5, 7, 8, 9, and then we want to find out the middle, the value in the middle position. So where is the middle position? The middle position is over here, actually, somewhere over here. So we don't have a exact value in the middle position. So in this case, we're going to find out the middle two numbers and then take the average of them, and that number would be the median in this data set. So in this case, the median would be equal to the average of this two middle number, 5 plus 7 divided by 2, which is 12 divided by 2, which is 6. So 6 is the median. Now once again, since in this case we only have 6 numbers, and we can find out the values of the middle two numbers, the two middle numbers very easily. But what if we have 5,000 numbers or 500 numbers? We cannot find the two middle numbers that easily. But what we can do is we can find out the position of the two middle numbers. Now let's take a look at how to find out the position over here. So actually, in general, in this case, this is actually this position is going to be n plus 1 divided by 2. The n is a simple size. So in this case, the n is 5. So 5 plus 1 divided by 2. So that's a general form, actually. And we're going to see a little more detail about this later. Now let's take a look at how to find out this the position of the two middle numbers over here. Now, since we have 6 numbers in total over here, and the first number we need is the third one. So that will give us 6 divided by 2 is 3. So it's going to be n divided by 2. And then the next number would be, of course, n divided by 2 plus 1. So once again, the n over 2 and n over 2 plus 1 are the positions of the two middle numbers. They are not the values of the two middle numbers. Okay? And I wish this is clear. Let's just take a look at the steps of finding the median of data set. Of course, that's pretty much the same as we just went over. Step 1, of course, we want to arrange the data set in ascending order, and then determine the numbers of observations n. And then determine the observation in the middle of the data set. So if the sample size is pretty small, we can just go ahead to pick up the middle number or the two middle numbers directly. But if the data set is too large, we gotta find out the middle positions. Okay. Oh, this is about how to find out the middle positions. If the number of observations is odd, just like 5 is odd, right? Then the median is the data value exactly in the middle of the data set. That is, the median is the observation that lies in the n plus 1 over 2 position. And then, of course, if n is 5, so 5 plus 1 is 2, divided by 2 is 3. So this is the third, okay? This is the position. If the number of observations is even, then the median is the mean of the two middle observations in data set. That is, the median is the mean of the median is the mean of the observations that lie in the n over 2 position and n over 2 plus 1 position. Now, once we know this, method here, let's take a look at this example. Actually, this is the example we just went over previously. Now let's take a look at how to find out the median of this data set. Is still those 7 numbers, and then we want to find out the median. First of all, we want to rearrange them in ascending order. So of course, it's 5, 18, 23, 23, 26, 36, and 43. Step 2, there are n observations, n is 7. We got to find out the value of n. So since n is odd, so we want to find out the middle position by applying this formula here. N plus 1 over 2, n is 7, so we got a 7 plus 1 is 8, 8 divided by 2 is 4. That means the fourth number will give us the median. Fourth number 1, 2, 3, 4, which is 23. That's how we got the 23 here. Okay. Now, this is a new case. Suppose a startup company hires a new employee. The travel time of the new employee is 70 minutes. Determine the median of the new data set. So once again, very similar. We want to rearrange the data set in ascending order, and like this, we get 8 numbers this time, and it's 8. So since this is even, so we want to find out the position of the 2 middle numbers. One is n over 2, which is 8 over 2, which is 4, and n over 2 plus 1, which is 8 over 2 plus 1, which is 5. So that means the middle 2 numbers are the fourth one and the fifth one. So 1, 2, 3, 4, this is 4 and 5. So the median would be equal to the average of those 2 numbers, which is 24.5. So of course, what they did over here is that they used the n plus 1 divided by 2, which is a 4.5. So when we're talking about position, it cannot be 4.5. But technically, 4.5 is somewhere between the fourth one and the fifth one. So of course, in this case, the median is going to be equal to the average of the fourth number and the fifth number. And that's how we got the 24.5 here. Right, once again, those 2 numbers over here, the 4 and the 5, are the positions of the 2 middle numbers. They're not the values of the numbers. I mean, they're not the values we're looking for. Okay, that's pretty much how to find out the median of data set. Now let's take a look at the relationship between mean and median and the shape distribution by going over this slide over here. Now let's take a look at the example again. So this is the previous example. We get 7 numbers here. Suppose a new employee is hired who has a 130 minutes commute. How does this impact the value of the mean and the median? So we want to say, how does this impact the value of the mean and the median? So first of all, I will say, comparing to those 7 numbers, 130 is a kind of extremely large number. Now, let's take a look at how this extremely large number affect the median and the mean after before and after. Now, first of all, let's take a look at the mean and median before the new hire. So based on what we went over before, we know that the mean before new hire is 24.9, which is the mean is over here. It's over here, 24.9. That's the same thing. Let's get back to that. And the median before new hire is 23. We just went over. So the mean after new hire, I wouldn't go over the whole calculation here. But what we need to do is just add them all up. 23 plus 36 plus 23 plus 18 plus 5 plus 26 plus 43, and then plus, of course, 130 at the end, and then divided by 8. And then you will get the mean after new hire is 38, and the median, of course, is the median would be 24.5, because if we arrange this data set in ascending order, that would be 5, let's say 18, 23, 23, 26, 36, 43, and the new number is 130. So the median, since we have 8 numbers in total in this case, and the median would be the average, the fourth number, fifth number, and which is 24.5. Now we can tell that before and after the new hire, the mean is going to be 38 from 24.9, but the median is only going to be 24.5 from 23. So we can make a conclusion over here, which is that the extremely large number affect the mean more substantially, and the median doesn't the mean is not affected by the the median is not affected by the extremely large number that substantially. And we call this kind of numerical summary is resistant. Let's take a look at this slide over here. A numerical summary of data is said to be resistant if the extreme values, when we're talking about the extreme values, it could be very large or very small. If the extreme values relative to data do not affect its value substantially. So comparing to the mean, the median is not affected by the extremely large number substantially. So we say the median is resistant, but the mean is not, because the mean is affected by the extremely large number quite substantially. Now once we know this, let's take a look at the relation between the mean, median, and distribution shape. So based on what we learned in the previous videos, we know this this kind of shape is called skewed left, and the middle one is called symmetric, and the right one is called skewed right. So of course, this is I think it's quite understandable. When mean and the median are equal to each other, we're going to have the symmetric distribution, which means that the observations with the highest frequency lies in the middle of the data set. So we're going to have a symmetric. Now let's take a look at the part C here, skewed right. So if it's skewed right, I will say there are a lot of extremely large numbers in the data set. And we know that the mean is affected by the extremely large numbers more substantially than the median, which means those extremely large numbers will pull the mean to the right further than the median. That's why we have the mean is greater than the median, because we have a lot of extremely large numbers, and those extremely large numbers will pull the mean to the right further than median. Because median is resistant, the mean is not. So similar to this case here, if the graph is skewed to the left, which means there are a lot of extremely small numbers, and we know that the mean is affected by the extremely small numbers more substantially than the median, then we're going to have those extremely small numbers will pull the mean to the left further than the median. So in this case, the mean is on the left of the median. Of course, the mean is is less than median in this case. So that's how we got it. If it's skewed left, mean is less than median, and if it's symmetric, mean is equal to median. If skewed right, mean is greater than median. That's pretty much about the relationship between the mean, median, and the distribution shape. Now after this, the very last definition in this part is called the mode. The mode of a variable is the most frequent observation of the variable that occurs in the data set. A set of data can have no mode, one mode, or more than one mode. If no observation occurs more than once, we say that the data have no mode. So let's take a look at example here. Let's say we have a bunch of numbers, 2, 3, let's say 7, 8, 7, 9, 8, and 7. Now what's the mode in this case? So if we want to find the mode, we just need to find the most frequent observation. Since we got 3 7s over here, we got three 7s over here, so the mode is 7. Okay. Now what if I put 8 over here? If I add one more 8 to the data set, we're gonna have 3 7 and 3 8s. So in this case, the mode would be 7 and 8 because both of them occurs 3 times. I think that's quite straightforward. Now let's take a look at this example here, finding the mode of the data set. The data on the next slide represent the vice presidents of the United States and their state of birth. Find the mode. So we have the raw data set here. They are the name of the vice president and the state of birth. We don't have to look through this because we have the frequency distribution here. So if we want to find the mode, based on the definition, we just need to find out the one with the highest frequency. So based on the frequency distribution here, the highest frequency is 8, corresponding to the New York. That's for this table here. And we got a second piece over here. We just need to say if there are any number greater than 8. Not really. So there's no number greater than 8. So 8 is the mode corresponding to the New York. So the mode is New York. That's pretty much how to find the mode of the data set. Alright, that's pretty much all about this video.